Hello and welcome to Module 12, Network Troubleshooting. So I think this chapter is very important because it's going to put everything that we talked about in the last few semesters. And if you run into any problems, you should have a way of figuring out as quickly as possible what the problem is. And of course, getting everybody up and running as quickly as possible. All right, so there's a lot of information in this chapter. So this is one chapter you should keep in mind as a reference. There's a lot of good information in here. If you ever get into an interview where you are going to be hired as a LAN administrator in any way, this is probably a good chapter to visit because most likely they'll be questioning you things about how to solve problems. And this is the chapter to go to. All right, without any further ado, let's begin. Don't forget to take all the notes that I asked you to submit them when we're all done. So we're going to start with network documentations. When it comes to network documentations, make sure the common network documentation you should include is, please write these 3 bullet points down: physical and logical network topology diagrams, network device documentation, and that records all printed device information, and network performance baseline documentation. This is very important. All network documentation should be kept in a single location, and the backup should be somewhere else, right? So write all of that information down. All right. Physical topology is how physically the devices are connected together and where are they connected, right? So the name of the devices and their interfaces. The logical devices, you want to know about the VLAN information and the IP addressing, the subnets. You would need to know all of that. So this is one thing that you can always use and look at on your first day on the job. You need to know the physical and the logical topology of the network that you're going to be responsible for. So there you go. So when you're first hired to kill the butterflies, you have a plan. So you go in and you say, all right, I want to learn about the physical and the logical topology about the network that I'm going to be working with. So if they have a document, beautiful, just go through it. And because eventually you're going to need to know it regardless to be able to expand, maintain, troubleshoot a network. You need to know how the physical and the logical topology behind it. Again, if they don't have it, you create it. Okay, and that takes time. They may take weeks sometimes to do this. All right, so now here's the network documentation that you may get. So this is you got the router devices, all of them, and you got to where are they located, what operating system, what licenses do these routers have? Do they have the security? Do they just have, whatever, depending on what they are. Then you got the device, again, another switch device documentation, and you got the end device documentation. All right, so this is a good example of how to document all the different, on the physical topology end, all the different devices that you may have. All right, establishing a network baseline. A baseline, you want to take a snapshot of what is normal operation, normal traffic on the network. So baselining is extremely important. So please write the last bullet, these 2 bullet points down. So you want to see what's normal. It may take you about 2 or 3 weeks. You need to be able to select step number 1, determine what type of data you're going to collect to create this baseline, right? So select few variables. Start with an interface and CPU utilization. All right, just take, it may take you a week, 2 weeks. Typically it's done, you should spend about 1 to 6 weeks to make sure you eliminate any anomalies or anything like that. And you may use this baseline information about what's normal, quote unquote, traffic, use it for an anomaly-based IPS system, intrusion prevention system. So if IPS sees something that is out of the ordinary in comparison to the baseline information, it may send you an alert. or block the data from coming in, right? But every once in a while, you have to keep fine tuning it because, it all depends on the type of network that you have and where you, and this way, by the way, you'll be able to know which way the data is coming from, which network creates the bottlenecking, for example, on a network. It all depends. All right. The second step, you need to identify the devices and ports of interest. All right. Use the logical topology to do that. Okay, so you'll know exactly which interfaces you want to do. And finally, you need to determine the baseline duration. How long is it going to run? Typically between 1 and 6 weeks. That's what is expected. All right, so please take a snapshot of this. These are all the different types of Cisco commands that you can use to collect data. The show version, for example, will tell you how much memory and VRAM you may have, the type of operating system that you got, right? A lot of these commands we've used already. So this is, and probably a good idea to take these commands and while you're doing your exercises, just play around with them, see what kind of data that is coming, what kind of data that you can get to help you diagnose a problem. Okay, so you only know, if you know these commands pretty well, any problem that you have will give, the more information you got, the better off you're going to be. All right, so let's go through a troubleshooting process. There's a process that you should go through. And of course, experience later on is what's going to count. So to become a great troubleshooter, two things need to happen. You need to know how the system works, exactly how it works. The more, the better. The more details you know about how the system works, the better. And the second thing is experience. The more, that's why documentation is extremely important. So, but in the very beginning, there's a process that you should follow to make it easier so you're not all over the place and wasting time. All right, so this is a typical flow chart that you could follow. You gather information about what the problem is, and then you try to isolate the problem and implement and correct, and then if it's fixed, wonderful, you document it. If not, then you start all over again. But typically, there are steps that you can go. So there are 7-step troubleshooting process that you should follow, right? And please take a snapshot of this. So one of the first thing you are going to do is you're going to define the problem. Okay, what is the problem that we're talking about? Is it a network? Is it a local host? Whatever. Then gather as much information as you want. Most likely, you are going to ask the host, who's the user, what kind of problem do they have? What's the device? Is it the router? Is it the switch? Is it a link? Whatever. Then you analyze the problem, eliminate the possible causes, propose a hypothesis, test your hypothesis to see if it works, and then of course you solve the problem. So it's easy to say, but in each one of those, you could take the following step. And this is probably the most important step. The first one is questioning the end users. So you need to please take a snapshot of this, right? There's a lot of snippets that you are going to take in this chapter, and they are all important. And you should have them on hand if you are going to be a LAN tech, for example, your response. Even if you are just a help desk, these are going to be extremely helpful. So when somebody calls in, or a client or a user comes in and tells you that they have an issue, so you're going to ask them, for example, what doesn't work? What exactly is the problem? Ask these questions. So what are you trying to accomplish? How does the issue does it affect you, or does it affect someone else? Would you be able to replicate the problem, for example, so you can see where, if you could do it again, and so on. So get as much as information that you want from that you can get from the user. Now, remember that sometimes the user may be reluctant to give you information because they think they may get in trouble because they might have done something to really cause the problem themselves. And sometimes you can get users that they think they're technical and they try to fix something and probably made it even worse. All right, but try to gather as much information so you can eliminate what the problems may be. You can go in there yourself, other than just asking users. You can use any of these commands. The ping command, the trace to check for connectivity, the show IP interface brief, for example, gives you a summary of all the interfaces to make sure they are all configured and up and running the way. Show the protocols to make sure that you're running the routing protocol and they are advertising what they're supposed to be advertising, and so on. So knowing all of these commands on the router or even the switch will enable you to isolate where the problem is. All right, now we can go into, in a second, don't forget to take a snapshot of this. Anytime you see any of these tables, please take a snapshot of it, because we are going to do all of them. Well, I want you to have all of them. And so don't forget, even if I forget to tell you, just do it. All right. You can actually troubleshoot a network starting either from the physical layer, go up, check the hardware to see if the physical devices are powered, for example, and you can move up the network all the way to see if the application, or you can go from the top bottom, or you can go, from the middle and go up or down. It all depends. So let's take one at a time. So take a snapshot of this. Here are the different approaches. You can do bottom up from the physical layer up. This is a good approach to use when the problem is suspected to be a physical one. You think the cable is bad, no power, you don't see the fans are running on the device. Top down if you think the application has an issue, right? From the application layer down. Divide and conquer. This is where you start in the middle. For example, you do a ping command. If it's successful, then the bottom 3 layers are good, right? It's probably a security issue, maybe a firewall. Then you start going up. If the ping is unsuccessful, then you try to troubleshoot the bottom 3 layers, right? So that's what divide and conquer is. You can follow the path, use a trace route and find out where the problem is, right? You can use substitution. If you take one card and put in another one to see if it works. You take another device from another machine that it's working correctly, and you try to plug it into your machine. See if that helps. You can compare, compare and contrast. And you can, of course, take an educated guess from all the knowledge that you have. And don't forget, you can always use your resources. Google is a nice resource, You go to different forums on the internet to find out if somebody ran into this problem. You'll be surprised. And no matter what happens, you document everything, especially when everything works out fine. You document is extremely important. All right, so there are software out there that allow to help you troubleshoot. There is the network management software. You can use knowledge-based softwares and baselining tools that will enable you to assist you in troubleshooting problems on the network, right? You got protocol analyzers like Wireshark that you can watch the data that is flowing. Okay, this is for performance issues. You can find out where all the data is coming from, for example. You got digital. Please take a shot of this for hardware troubleshooting. If you're at the bottom layer, you got the digital multimeters. Figure out the voltages, the correct voltages and currents that are in resistance at the circuit level. You got cable tester to check continuity, to make sure that the data can get to the end and back. Cable analyzers, portable network analyzers, and the Cisco Prime NAM. So these are actual hardware that you can have to test cables and devices to make sure they are okay. All right, so I'm going to stop right here. We'll continue with this on the next video. So write everything down, and I'll see you in the next video. Submit.